Yes, students. So, welcome to today's class. Yes, very good evening. Sorry, very good afternoon to today's class. Okay, and we'll be starting today a numerical session. So I hope it's visible on the screen. Yes, it's here. So today we are going to start a numerical session on wave optics for today's class. Okay. Next class will start the theory because some students are having a lot of doubts in numericals, and also yesterday's class was not like it was not fine, due to some external issues, surrounding issues, so that's why the class was not fine. So first we'll do the numericals based on what we have learned till now. Okay, and after that from the next class we'll see the theory again. Okay, so today is just the numerical session in front of you. So please, everybody join fast. I hope it's visible properly to you. Things are clear, no? So I hope it's visible. Okay. So we are going to start it soon. I hope I'm audible properly and the sound is clear. I hope I'm audible properly and the sound is clear to all of you. Isn't it? Please join fast. Okay. So we'll start it soon. I'm waiting for other students to join. When you will join, then only we can start, no? Okay. So let us go through the first question now. So this is your slide, and here we go for the next question. So see, before starting the numerical session, we must go through the contents list. Okay, is it fine? We'll go through the contents list first. So as you can see here, this is in front of your screen. First, we'll, as the session is what numericals, so we'll solve the numericals. We know what it's common sense. Okay, after this, we'll see the basic numericals. Okay, after that, we'll see the average numericals. After that, we'll see the tough. So numerical session will proceed like this, starting from a basic questions in between, some average level questions, and then tough level questions. Okay. So this is question number 1. Okay, for you. Don't worry, we will not solve a lot of questions. I mean, the explanations will take time. So approximately 10 to 12 questions we'll try to solve. Okay. How much? 10 to 12 questions. So here is the first question in front of you. It is asking from you this, that shows a wavefronts in still water. Okay. Moving the direction arrow towards interface PQ. Suppose this is an interface PQ. PQ is what? An interface. Okay. And these are the wavefronts which are moving. Like this. Okay. It's fine. So this is a shallow portion and this is a deep thing. So they're asking here that these are the still water, the moving in the direction of the narrow arrow towards the interface PQ between shallow region and a deep, denser region. Which of the lines shown may represent one of the wavefronts in deep region? They're asking. So you have to answer which is the line among these four lines. First, second, third, fourth. Which among these lines may represent one of the wavefronts in the deep region? Which are those lines? Okay, so what is your answer? I'm giving you 2 to 3 minutes for the solution. Please answer me in the chat box. A, B, C, or D. What is your answer is? A, B, C, D. What is your answer? Okay, I'm waiting for a solution. So answer me in the chat box. What is your answer? A, B, C, or D? A, B, C, or D. What is your answer? Anybody is there to solve? So I'm giving you 2 to 3 minutes for this. Please solve it. Okay. Let me check meanwhile the YouTube students, what they are doing there. Let us see the YouTube students. So please answer. Okay. So I think it's clear to all of you. I mean, how to solve it now. If it's not, I'm giving you the solution. So watch the solution carefully. Okay, fine. So see it carefully. How to solve this. Just wait for a second. Okay, so here we are. I think there is no network issues. No, everything is fine. Yes. Okay. So see, the answer will be this. That is, when the ray is going like this from a shallow to the deep, fourth will be the answer. Okay. And let me explain you how it is. So this is how refraction take place. No. Suppose you are having, I'm showing you this screen. Okay. Suppose you're having a line like this interference. Okay. And then what is happening? Suppose a ray is coming like this. So when it will refract from it. Okay. What happens? It will go like this. Simple logic. Okay. So this will be the answer. That is the fourth. Fine. Okay. Now let us see the next question. So this is the second number question, which is asking from me like this, that two coherent monochromatic light beams of intensities I and 4I are superposed. Okay. And then they say like this, the maximum and minimum possible intensities in the resulting beams are what? So these are the options: 5II, 5I3I, 9II, or 9I3I. So among these four options, A, B, C, D, you have to tick any one of the options. Okay. Among these four options, you have to tick any one option. So I'm giving you 2 to 3 minutes for this. This is the second number question. Solve it yourself. Okay. So here your time starts now. Okay. So Janvi, Dhamitra students have joined. Welcome to today's class, Janvi, Dhamitra students. I hope I'm audible to all of you properly. Okay. I hope that there is no any issues in audibility. Okay. Now because I've connected like both the audios are like instruments are available here. Yeah. Okay, good. So Genevieve, Dimitri, students, you don't waste your time. Don't wait for other people. Just start it solving. Okay. So it says here two coherent. Today's session is, let me tell you again, today's session is completely numerical. So we'll start up with numericals, basic, average, and tough. We have done this numerical. You can see the video on the YouTube. Answer is fourth. Now, since you have joined now, so I will explain this numerical again. I mean, not the solution, but the question. Okay. See what happened yesterday's session was not good due to some external technical issues, some external surrounding issues. Okay. So today I've decided that before going towards the yesterday's topic, I mean, following the yesterday's topic, that is diffraction, I must start with the numericals first. So till the day before yesterday or your previous to previous session, till that, whatever we have studied, we'll solve the numericals based on that. Okay. So be easy. No theory now for today at least. So this is the question in front of your screen. There are two coherent sources. Coherent matlab frequency constant, del constant. Okay, fixed. Monochromatic matlab having the common same wavelength. Two coherent monochromatic light beams of intensities I and 4I are superposed. They're overlapped. They're asking the maximum and the minimum possible intensities in the resulting beam are what? 5I, 5I3I, 9I, or 9I3I. ABCD is the option. I'll give you 2 to 3 minutes to solve it because it's a class illustration. Then I will give you the solution. Okay. So your time starts now. Since it's a class illustration, please, Genevieve, Dimitri, students, solve yourself. You are having 2 to 3 minutes for this. Okay. Then I'll give you the solution. How to solve this question. Okay. That's fine. So your time starts now. If you are not able to solve, please reply in the chat box, sir, solve it yourself. Or sir, we have solved. This is the answer. Okay, I'm waiting for 1 more minute. Okay. So, JNV Dimitri students, have you solved it? No? Okay. Now, I'll be giving you a very good solution of this, proper, precise solution of this. So, please focus here. Okay. So, if you see the question carefully again, let me highlight it. Okay. It says two coherent monochromatic light beams of intensities I and 4I are superposed. Okay. The maximum and minimum possible intensities and the resulting beam are what? They're asking you this. Simple. Okay. So let me give you the answer. I max is equals to under root I1 plus I2 square. Okay. See, I1 here is given as what? I1 here is given as I. I2 here is given as what? I2 here is given as 4I. Okay. Okay. So I plus 4I square will give you what? It will give you 5I ka square. I max is this. Okay. If we see the I minimum under root I1 minus I2 is what? I minimum, students. Okay. This is the formula. So now put the values directly. Simple. I1 is how much? Okay. There is one issue in this question. You know what's the issue? We did some mistake here. Let us erase this thing. That's fine. This is under root I and this is under root 4 because I1 is this, I2 is this. Now under root I is under root I, but under root 4I is equals to what? Twice of under root I. Okay. So I'll put here under root I plus twice of under root I. This will give you the answer as equals to 3 under root I ka square. And the answer will be 9I. Okay. So this is the I max value. Fine. Now we'll see the I minimum value. See, this formula you must know. If this you know, then it's good. Otherwise, there is a problem. Okay. Then I minimum is given by this. Now let's put the values. You can put any of the values because square is there. So let me put here 4I and let me put here just I. So my answer will come as to be twice of under root I minus under root I square. This will be under root I square will give you I value. Okay. I minimum, I max value will be given as, now I max value comes out to be 9I and I minimum value will come out to be I here. Okay. So see, you can see from the options, the question, as per the question, they're asking us the maximum and the minimum possible intensities. So maximum is 9I and minimum is I here. Maximum is 9I and minimum is I here. Okay. So as per, you can see the option, maximum is 9I and minimum is I. Maximum is 9I and minimum is I. Maximum is 9I and minimum is I here. Okay. So students, is the solution clear? If you are having still any doubt, please ask in the chat box. Okay. I hope the solution is clear to you. Two coherent sources, the maximum and minimum possible intensities will come like this. What is a 9I and a I is the value. C is the option. And the formulas which we have used are what? We've used for I max as, remember this, why I'm writing it? So that you may remember the formula for all this. Okay. Under root I1 plus under root I2 का square. I minimum is under root I1 minus under root I2 का square. Okay. Put the values you'll get for this and this for this. So option is 1 and I mean 9I and I. C is the option. So we see among all of these options, what is the correct answer? Correct answer will be this C option. Okay. So students, is this thing clear? Please reply in the chat box, Demetri students. If it's clear, I'll proceed towards the next question. If this solution is clear, I will proceed towards the next question. Okay. I'm waiting. 1, 2, 3, 4, 5. Your time is up. Now we'll go. So this is the next question in front of you on your screen. You can see it. See, this question says there is a figure shown here to you people. This is a figure in front of you. And it is having the plane waves refracted from air to water. So this is air medium. Remember, this is what? This is air medium and this is what? This is water medium. So rays are getting reflected from an air medium. See, those all students who haven't joined today's session, no, actually they have missed a very big thing. Because yesterday's session was due to some, surroundings issues. But today it's a very good numerical session. If you're not joining, it will be problem for you people. I mean, not for you, I'm not telling for you people who have joined GNB Demetri students, but for other students. Now just see the YouTube students then now just see the YouTube videos afterwards. And I know you will not see because, you're busy in the school schedule. Okay. So this is what air and this is water. Suppose the plane waves are coming like this, refracted from air to water. So they're asking using Huygens principle. A, B, C, D, E are the lengths on the diagram. The refractive index of the water with respect to air is ratio. Okay, so they're asking you have to find refractive index of water with respect to refractive index of air Okay. In terms of these letters A, B, C, D, E, what it will be? Will it be A upon E? Will it be B upon E? Will it be B upon D? Or will it be D equals to small d upon small b? All letters are small. Remember this thing, we already know that refractive index of water is something which is equals to 1.3. And for air, it is 1. So by the way, if you see the numerical value, it comes out to be 1.3. But this is not our answer. We have to answer in the terms of lengths A, B, C, D. If this is a planar wavefront goes from air to the water and it gets reflected, this is angle of reflection for this. This is the angle, not this. Let me erase this. So I need to erase this. Yes. So this is angle of incidence, this is angle of reflection. So when the light ray goes from a rarer medium to a denser medium, it will bend towards the normal. Okay. Okay. So you have to find the value whether it is A by E, B by E, B by D, or small d by B. What is the values? Okay, you have to find the values here. What is the value? A by E, small b by E, small b by D, or small d by B? Anybody? So I'm giving you 4 options. Okay. I'm giving you 2 minutes. 4 options are there. I'm waiting for a solution. Your time starts now. Okay, so one of the student have texted, replied. Okay, so JNV Demetri student says C is the answer. Okay, we'll see that is C B by D, that is small b by D is the answer or not. Okay, so let us solve it now. So I'm giving you a solution here, providing you a solution here. Just watch it carefully. Okay, good. So Mansamita and Subhashmita have joined. Excellent. Okay, so maybe you are from different JNVs. So please focus here. We are solving a question. This is a question in front of you on your screen. So a rays, a planar wave, like it's a wave, okay, plane wave like this. It's going from a air to a denser medium. That is from a rarer to a denser medium. This is a denser medium here. Okay, it's a denser. So of course, when the ray goes from a rarer medium to a denser medium, it will bend towards a normal, and such angle R, which is the angle of refraction, is smaller than the incidence angle, which is in the rarer medium. Okay, this all the things we know already. But they are asking us, you have to find refractive index of water with respect to refractive index of air in terms of these letters A, B, C, D, E, and the options are A, B, C, D, capital. Okay. So now I will solve it directly. So see carefully. So suppose you are having a boundary which is separating two mediums, water and upper is air. And this is a normal to the boundary. Suppose the waves are entering like this as it is shown. One wave is entering like this and there is a distance, and then other wave which is entering enters like this. Okay. See carefully. Yes. A is the distance between these two. This is C. This is B here. This is D here. So I have to connect this, and the point E is where? Yeah, this is the E distance. So students, this is a C distance, and this is A distance. This complete distance is C. Okay, I'll provide you the solution here. So all have joined. That's very good. Okay, welcome to today's class, students. Yesterday, you people left early because I just wanted to tell you ki yes, due to some sorry for the inconvenience. Yesterday there was some surrounding technical issues. Okay, so due to that, the session was not good. Even on the YouTube, you can find the video. It was not cool there. I mean, it was not in consistency. Continuous. Today, what I did today before starting, I thought that let us start. So because all of you have joined now, that's why I'm explaining it again. So today I have started a numerical session. We still have 30 minutes. So we'll be solving now numericals continuous. Okay. So I will not explain again. I will not switch back to this first slide again now. Okay. So today's numerical session, let me give you a hint for all of you because you all have joined. We'll start with basic, average, and tough numericals. Once first numerical we have solved. Today we'll not see any theory because otherwise it will be very boring. Okay. We have to first solve the number of class illustrations now. So this numerical, I have solved it before you, the first comers, these Demetri students have seen this. Now, after this, I'm on this numerical. Okay, so let me solve it first. Then you will see the third numerical properly. So here I have to answer refractive index of air with respect to, refractive index of water with respect to refractive index of air. Fine. So see this student, it's very easy. First of all, if this ray is going from an air medium to a water medium, that is a denser medium. If I say this is a normal, this will be the angle of incidence and this will be the angle of refraction. Okay. Similarly, if I draw a very small normal here, for this, it will be the angle of incidence and this will be the angle of refraction. Okay. So you have to just apply the simple laws here. See, these both are rays are parallel. So I and I will be same. So I'll apply like this. I will say sine I will be what? Sine I. Sine I का मतलब क्या होता है? What will be sine I here, students? If you draw, anybody can answer? If you need to find sine I, what it will be? Any one of you? Sine I. Okay, sine I, anyone? So let us see it. See, sine I will be here like this. This is I. So sine I will come out to be B by C. Very good. Okay, Chhattisgarh students have joined. Excellent. So sine I will come out to be B by C. Now, if you see sine R, that is this angle. Okay, because these are parallel angles will be same. So this will give you the value equals to D by C. Check. Just watch it fast. Okay, because most of the students will be able to understand the next question. You have joined in between. So from first and second equation, if I write here properly, from first and second equation, I can say like this. We know the formula of the Snell's law, application formula. What was that? N1 sin I equals to N2 sin R. So you have to put this I and R angles here, okay? I mean sin I and sin R here, B by C and D by C. Sin I is B by C. N1 is incidence angle kahan pe hai? Incidence angle is in air, okay? So we'll say 1 here. N2 is for what? For water. So I'll put here C mu. Let us take mu water to be this general value, not anything. Okay, I mean, I'm not putting the numerical value because we want in ABCD terms. Sin R from the second equation is how much? It's D by C. Put here D by C. So you will get the answer that mu of water. Okay, let us not put the value of this. Mu of air. Let us take it as mu of air. This will give you the value, students, equals to B by D, which is your answer. So this will be your answer of this illustration. So it's all geometrical. Those students who are having good geometrical skills, they will be able to solve this question. Okay. So today's a lot of students have joined. Thank you so much. So come every day, because either you will be sleeping this time or maybe doing some other work. So it's better to join the class. You will gain the things for your competition. You will get prepared automatically for the competition exams. Okay. Very good. Excellent. So see, the answer will be B by D. Fine. This is our answer. Let me highlight this. B by D is your answer. Now, students, for all of you have to join it. Okay. I mean, all of you have to solve this numerical now. It's very compulsory. That is fourth question. Students, this question is easy. Also, it will, revise your previous concept of ray optics. Okay. So the question is this: when a light is refracted into a denser medium, remember what the word is. What is this? Refracted. When the light is refracted into a denser medium, four options are in front of you. Its wavelength and frequency both increases. Its wavelength increases, but frequency remains unchanged. Its wavelength decreases, frequency remains unchanged, constant. Wavelength and frequency both decrease. So you have four options, A, B, C, and D. Read the question properly again if you want and answer me. I'm giving you 2 to 3 minutes. No. I'll give you just 2 minutes to reply in the chat box. Okay. So your time starts now. Anybody's replied? So I'm giving you most like 30 seconds are left. Okay. So 1 to 2 minutes, 30 seconds are left, maybe. Okay. Option A, let us see. Option B. Okay. Jinvi Dimitri student says B and Swapn Jinvi Khorda student says A. Let us see, students, this thing, the solution. Let us now see the solution. Okay. Suppose this is a boundary which is separating two mediums. Okay. And this is a perpendicular to the boundary. Okay. And suppose if the light ray is entering like this is a light ray. This is the angle I which the light ray is making with this normal. This angle I is known as angle of incidence. This angle I is known as angle of incidence. Okay. Fine. This is angle of incidence. And we know this thing. If the light ray enters from a rarer, question is what? Refracted into a denser medium. So when the light ray enters from a rarer medium to a denser medium, then what's going to happen? It will bend towards the normal. Okay. So this will be the R angle. Now, angle of I is greater than the angle of R. Angle of incidence is greater than angle of refraction. Remember it always. Okay. So if we comment on the light ray, see frequency, if I talk about, no, frequency is defined as what? C by lambda. Frequency is C by lambda. Okay. We know this thing that how the C changes. Okay. So I will say if the lambda is changing, frequency will change. Okay. What's the next thing? They are commenting about the frequency remains unchanged and increase. Okay. So see what happens actually when the light ray enters from a rarer to denser medium, there is a change in speed. C will be get changed. So when the light ray enters from a rarer medium to denser medium, if the light ray is having the C speed in the rarer medium, remember it properly. If the light ray is having the C speed of light, 3 into 10 to the power 8 meter per second speed in a rarer, that is vacuum or air, vacuum, okay, more precisely if you say vacuum, and it enters into denser medium of refractive index, say N, then the new speed in the denser medium Vd will be subscript D will be equals to how much? C by N. Remember it. So if I apply the formula of the frequency, I'll get this thing that speed is now C by N. Okay. So frequency is changed. So I'll comment like the students, ki I'll keep the frequency to which frequency will change and lambda will remain constant. Will not comment on lambda. Lambda is same, frequency will change. Remember it. According to this, if we see, frequency will change, but lambda will remain constant. Okay. But this can't happen, students. Okay. See here. It says, according to this, if you apply this formula, it says like this, frequency will change and lambda will remain constant. But is this true? First of all, tell me the answer. Is it true? What do you think? Is it true or false? Because if we take two waves, if lambda for one is this, and for other, if we increase the frequency, it will be this. So lambda is decreased, no? So what is happening, students? Remember this thing. When the wave enters from a rarer medium to a denser medium, there is a change in both speed also and lambda also, such that the frequency remains constant. This is a true answer. Okay, remember it. So I'm writing it properly. When a wave enters from a rarer medium to a denser medium, okay, frequency remains constant. But how it will remain constant? It remains constant in such a manner that how, students? Like this. That is, focus here. We'll say that the C will also change. So speed changes and wavelength also changes by some manner. Okay, such that both of this change will create again the same constant value. So if I want to say I want to put here 2, I can bring this 2. I mean, I can bring this 2 on the left hand side. How? Either I must divide this 4 by 2 or I must divide this 8 by 4. Although we can see now numerator 4 gets doubled and 2 gets doubled, but still the answer will come out to be 2 only. So that is the same here. Frequency is given by C by lambda. When the light ray enters from a rarer to denser medium, I'm telling here again, okay. So C will change by C by eta. Also lambda will change somehow, but the mu value, that is the frequency, value will remain constant always. Okay. So our answer is this now, that when the light ray enters from a rarer medium to a denser medium, frequency is constant. Okay. And the lambda will decrease. The lambda will decrease. So the answer is frequency will remain constant and lambda will decrease. So what is the answer? Where is the decrease value? Yes. So C is the option, students. What is the option, students? C is the option. Wavelength lambda is decreasing. Frequency is unchanged. That is constant. Okay. Now let us fast approach towards the 5th question. See, this is a question for you people. This question I'm giving you as a homework. We'll solve the 6th question because we are having less time. Okay. So the question says like this: 2-point sources are separated by D equals to 5 micrometer. So these are the two sources of light you can take. And a circular wire of radius 20 micrometer is placed around the sources. This is a circular wire. Okay. You have to it's very easy. Just see it and comment. That point A and B will be having the dark spots or brighter spots. And what about point C and D? Okay. So you have to comment this thing, and this is your homework. See, we have seen the interference experiment. No, that what was happening. Okay. Suppose this is a light source and light rays are passing like this. And on this, if we see the bands here, so there are different bands. This will be the brighter band. This will be the brighter band. And in between, there will be darker and darker band. Similarly, here also, if these are sources of light, it will give you a different band region here, dark spot or bright spot. Okay. So this is homework for you. You have to check it out, what it will come. Now let us see this question. Yes. So this is a good question, and now try to solve it. I'll read a question for you. I'll read this question for you. Just look here carefully. So it says like this: plane microwaves from a transmitter are directed normally towards a plane reflector. Okay. A detector moves along the normal to the reflector between the positions of 14 successive maxima. The detector travels a distance 0.13 meter. Velocity is this. You have to find the frequency of transmitter. A, B, C, D are the options. I'm giving you 2 to 3 minutes for this. Try to solve it. See, don't feel fear, like big questions are there. How we'll solve it? Okay. So you have to go through it. Okay. A, B, C, D are the options. Solve it. Okay, students. So I'll explain you. I think it will be difficult for you. Okay. So as it is written here, plane microwaves from a transmitter are directed normally towards the plane reflector. So let us draw a diagram first. So always whenever big questions are given, you have to draw the diagram. It says plane microwaves. Suppose this is a transmitter. This is transmitter. Plane microwaves are coming like this. Okay. And reflector is here. This is what? Reflector. Okay. So the microwaves from a transmitter, it is sent normal to the reflector. Okay. A detector moves along the normal to the reflector. So this is this is actually a normal to the reflector, and there is some detector moving. Maybe with some speed it is moving. This is a detector. Okay. It moves normal to this reflector. Remember it always. Okay. Then they say like this: between the positions 14 successive maxima, the detector travels a distance 0.3 meter. Okay. So see, between these there are different maximas. And maximas means, suppose, bright spots, consecutive 1 2 3 4 5 1 2 3 4 5 6 7 8 9 10 11 12, okay, 13, and like this. So, and in between there are dark spots, remember, like this. These are some, hold on, let me remove it. Yes. So what happens when this detector is moving? These are the dark spots, these are the bright spots in this, something like this, okay, on this reflector. Okay. So what happens? It says in between when it moves, there are 14 successive maximas, and distance which it has moved is 0.13 meter. See, if you're not understanding it, assume like interference pattern, that suppose you're having a screen, you're having a bright spots, you're having a dark spots, bright spots, dark spots. This will be the pattern, no? So think like this. See, one will be on the center, that we count as y equals to 0, remember always, hai na? So we'll consider like this, that 13, what is the formula of bright spots? It's n lambda d by d, hai na? For dark spots, it was 2n1 plus lambda by 2 capital d by d, hai na? But we'll just see the values. Okay, remember, we'll just see the values. So we know that part, let us take the part difference. Let us not take the y value, let us take the part difference. If you focus on the part difference for constructive, that is maximas, the part difference was n lambda. And remember, for destructive, the part difference was 2n plus 1 lambda by 2. Okay. So if I put here n equals to 0, this will give me lambda by 2. N equals to 1, this will give me 3 lambda by 2, like this. But isme if I'll put n1 lambda, 2 lambda, 3 lambda, 4 lambda. Okay. So distance which it has moved, it's written here on the screen, distance which it has moved, detector travels a distance 0.13 meter. Okay. Between positions of 14 successive maxima, between positions of 14 successive maximas. Okay. So I will use this. Between maximas are what? Dark spots. So I will say I will use these values. Okay. So if it is 14 for maximas, so it will be -1. I mean, usse 1 less. That is 13 for this minima. So I will use the value equals to 13 lambda by 2 equals to 0.13 meter. And the answer which will come out to be, it will come out to be, say, lambda equals to 0.002 meter. Okay. No, hold on. This will come out to be, see, if you revise the concepts, no, you'll be able to understand it in 1 second. 0.02 meter. And I can say it will be equals to, say, 2 centimeter. This is the lambda. Let us check the options. They are asking us what? They are asking us the frequency. So transmitter ka lambda is 0.002 meter. Frequency is defined as 3 into 10 to the power 8 upon lambda. Lambda is 0.002 meter. So this will give you 10 to the power 2. Okay. So the answer is 1.5 into 10 to the power 10 hertz. So our A is the option, students. Our answer will be A. Okay. So is this solution clear? I'm showing you again this solution. Watch it carefully. This is the first value. The second value is in the down. So For maxima, if it is n, for minima, it will be n minus 1. Put the values here, and lambda will get this. Lambda is equals to what? Frequency is what? C by lambda. Apply this formula, we'll get the frequency here equals to 1.5 10 to power 10 hertz. Okay, A is the option. Mark it carefully. Is this solution clear? Please reply in the chat box. Students, if this solution is clear, please reply in the chat box, because now we'll solve the last question. So this is the last question of the class. Not this question. Yeah. Okay, so this question, 9th number question, this is the last question. Solve it carefully. I'll give you 2 to 3 minutes to solve this. Then I'll give you the solution, and then we'll end the class. Okay. So this question for 2 to 3 minutes, and then we'll end. Reply in the chat box answer, and then I'll give you the solution. Okay. Okay, let us see the solution. Okay. So the experiment is what? It is YDSC. YDSE. What does this YDSE stands for? It stands for Young's double slit experiment. Young's double slit experiment. Okay. So see, the experiment is this. Suppose you're having a source of light here, and this is slit S1, and this is slit S2. Okay. And the light rays are passing like this. Light rays are passing like this. We know light rays after passing. See, this is source of light. There was one more slit, but I have directly drawn the 2 slits, S1, S2. Light rays are passing from this. After passing, they will get interfere, and on the screen a pattern is formed. This is a central maximum. This is a dark band, then maximum, then dark band, then maximum. This max, max, max. And similarly in the minus y-axis, it will be maximum. This is central maximum. This is maximum, like this. Okay. So now they'll be asking from you, as in the question they asked, if in this experiment, the light of the wavelength 200 nanometer is used. This is lambda equals to 200 nanometer is used. Okay. And D is 700 nanometer, which is what? D, small d is equals to 700 nanometer, which is actually what? Distance between the slits. Okay. So now you have to find the number of maximas which can be obtained. Maximas matlab, maxima ka matlab hai bright spots. The number of bright spots which can be obtained on the screen. They're asking you now. Okay. So remember, we know the y positioning of the maximas. If we see the y position of the maximas with respect to the central maximum point, that is y0, was equals to, by general formula is given by what? N lambda capital D by D, where n is the integral multiples, n0, 1, 2, 3, 0 is for the central maximum. Lambda is the wavelength of the light used. D is the distance between the screen and the slits. Small d is the distance between the slits. Okay. Now put this value here. So we know lambda is how much? 200 nanometers. Lambda uses 200 nanometers. Okay. and small d used is 700 nanometers. Capital D is how much? They're not given. They have not given this value. Capital D. Distance from the screen they haven't given. So what to do? So by you saying by when we use this formula, we know this thing now. We can't get the number of maximas like this. Okay. So now I'll use the theta rule. Theta, there was one value which was theta. It was given like this. Theta equals to n lambda by d. If you remember, sine theta was there, no? So we applied when theta is very small, sine theta is approximated to be theta. So we can say n lambda by d, and theta means stands for what? If I see the experiment, इसमें two slits are there. Suppose the rays are passing like this, okay, and there is a screen like this. Suppose this is the angle theta made. So as this theta is turned from this y0 matlab theta 0. So as the y linear distance, see it's like the angular and the rotational variable relationship. Suppose theta on the wall is increasing. So this will be the y position. If theta increases, y increases. If theta decreases, y decreases. If theta is 90 degree, y will be say infinite. If theta is 0 degree, y will be 0. That is bright spot, central maximum. So we'll use now theta value, because see, whenever you get confused in the exams, now use this approach. No need to directly go to the formula. Since that is not working, we have checked it. So now next methodology is what? Use the theta. Sine theta approximated, theta for small is what? Theta. We'll use n lambda. Hold on. We'll use it like lambda by, no, don't use s, we'll use lambda by d. Okay. So lambda by d, if we see, it is coming as 7 by 200 nanometers. Okay, 7 by 200 nanometers. And number of slits we are having are what? 2 here. So 700 by 200 is a nanometers. Nanometer matlab 10 minus 9 meters. Okay. So this is the angular variable value you are getting. Okay. But this will be produced how? Actually, students, this question mein kuch error hai. There must be distance given. So you have to take the distance of the screen is equals to 2 meter. Okay. There is some error in this question. You have to take distance is equals to 2 meters. Okay. So through this, you will get like this. So suppose if you are given, see, let me tell you the logic. If this is a screen, if you're given theta equals to something, say theta degree, okay, and you have to find the numbers of points here. Okay, so how you can find? You can find like this only, r into theta will give you an arc here. If the theta is small, this is a straight line. So similarly, this r here is given as d equals to 2. Put the value here. You'll get the answer as, for the number of spots, we'll get as what? 7. So the maximas is like this. This question, students, will again solve in the next class. I will check it out that from where, whatever the module of this question is like given to me, I'll check whether there was some initial part of that or not, because this is incomplete question. Okay. If we use different approaches, we'll get the answer. But taking the answer is not our mission, not our goal here. We must go for the concept. Last question, students. I have to end the class now. Okay, leave. So I have to end the class now. This question, take it as a homework, which I've given you already. Now this question, okay. We'll start in the next class with the revision of this question, and I mean next week maybe. Okay, if anybody is having any doubt, can ask. So this was all about today's class, students. And now you can leave the class, okay. This was all about today's class. Now you can leave the class, students. If anybody is facing any doubt, can ask in the chat box. Thank you so much for your class attendance and study well, okay. I think you're not having a lot of load. Solve XCV. See if you can solve XCV books. I mean Harish Chandra Verma, Concept of Physics, Part 1. Wave optics maybe is in the, it's in the Part 1. So try to solve it. If you are able to solve it, then it's good. I mean, these are the signs these are the signs. I mean, SIGNS. I'm saying that. These are the, hold on. So these are the signs that you are really able to understand the things, okay. SIGNS. If you solve the questions, these are some measures, milestones that yes, I'm going near to what? My target of achieving good marks and rank. These all things. Okay, bye bye Morani and all the students, Jingi Dimitri students. Bye bye everyone. Take care, study well. Okay. Now I'm going to end the class. Bye bye all the